Hello everyone. Today we have this interesting problem, which is 9 over a9 equals 1 over a plus 1 over b. And our goal today is to find unique positive, well, not unique, because a and b are interchangeable here, but our goal right now is to find positive integers a and b such that this equation holds. Alright, so first, there's fractions, and then we all know that we don't really like fractions right here. They're not really easy to work with. So therefore, the first thing I'll be doing is to try to convert this equation and try to remove the fractions. So how do I do that exactly? Well, first I'll be adding these two fractions up. So it becomes 9 over 89 equals, so their common denominator would be AB. So this means that we multiply the top and bottom here by B, and we also multiply the top and bottom here by A. And what do we get at the end? We get A plus B over AB. And the entire reason why I did that is because now I can cross multiply. So precisely, I can multiply both sides by AB first to get 9 over 89 AB equals A plus B. And after that, I can multiply both sides by 89. And what does that become? This becomes 9AB equals 89A plus 89B. And putting everything to one side, this gives 9AB minus 89A minus 89B equals 0. And now we will be factoring this equation. And this is what we call Simon's favorite factoring trick, or SFFT for short. And basically, the factoring form is this. So it'll be C1A minus C2 times C3B minus C4. And this would equal C2 plus C4. No, C2 C4. And this is because after we expand everything out, we have an extra C2 times C4 term. So basically, what we do here is that we add a certain constant to both sides of this equations, and by adding this constant, this will allow us to factor it into this form. Now the first thing to know here is that, well, A89 is prime, so, and also C1 times C3, like if we expand this equation out, we get C1, C3, AB. And by matching both sides of these equation, we note that C1 times C3 equals 9. Well, it doesn't really matter like which two integers, like you can set C1 equals 9 and C3 equals 1. It will be like the same. We'll like either way we'll get the same answer. But for now, let's set C1 equals 3 and C3 equals 3. And now what remains is finding C2 and C4. Well, after we expand everything out right here, let's find like what's the coefficient of our variable A. Well, it'll be negative 3 times C4A. And the coefficient of A right here is negative 89. So therefore, we must have C4 equals A9 over 3. So it'll be 89 over 3 right here. And by similar reasoning, C2 also equals A9 over 3. So we will have this. And well, again, there's fractions right here, so we don't really like fractions here. So therefore, we can multiply this by 3, or we can also multiply this by 3. And after doing so, we multiply like this entire equation, both sides by 9, essentially, and we get this. Okay, so here, now we recall that A and B are positive integers. So therefore, 9A minus 89 is an integer, and 9B minus 89 is an integer. And their product equals 89 squared. Now, because both of these are integers, by definition, these must be divisors of 89 squared. So all there remains is to find divisors, like positive divisors of 89 squared. So these would be 1. So what are positive divisors of 89 squared? Because 89 is prime, so this is convenient. So the positive divisors are 1, 89, and 89 squared. Okay. So we can try values. So let's say 9a minus 89 equals 89. So this means that 9b minus 89 is 89 as well. However, if you try to solve for a and b, you realize that they are not positive integers. So therefore, 89 is out. So we set 9a minus 89 to 1. And 9b minus 89 to 89 squared. Now you may also notice that you can do it the other way. You can set this to 89 squared, you can set this to 1. However, our answer will still essentially be the same because these are commutative, right? Like if you switch a and b around, like the sum will not change. And all there's left to do is to solve for a and b. So we have 9a minus 89 equals 1, and 9b minus 89 equals 89 squared. So we have these two equations down here, and solving this gives us ab equals, so a would equal 10, and b right here would equal, I believe, 890 right here. Yeah, 890. And well, if the problem asks you to find all ordered pairs, well, you can definitely switch AB around. So the complete solution will be this. And we have this. We have this as our final answer. So yeah, like if you look at all the writing on the board, you'll see that this is a lot of steps, right? So now there's a second method, and it's much quicker. It's it's a nice trick. I see. Like I didn't find out at the start. So please welcome my sister, right? And she'll be explaining
Hello.
the second method.
Okay, so first we're just gonna erase all of this because I don't want to see it. It looks complicated, and it gives my brain a headache. Okay, so my method involves playing with numbers because numbers are like mathematicians' favorite toys. So we can see, so 9 over 89 equals 1 over A plus 1 over B. Now, we could play with them and try to times these numbers because 89 is a prime number, so we have to turn it into not prime, which means we have to times the numerator and the denominator by a number. So the first number that comes into my head is 10 because it's a special number. So we could times the top by 10 and the bottom by 10. So then it's 90 over 890, which equals that. So we can see the unit up here is 1. So we can minus 1 from here. 890, and then this is 89 plus 1 because there's already a 1 here, so it's going to be that one. Okay, now we know this, we can separate them into 89 over 890 plus 1 over 890. Now we already know one of the answers, which is B. So we already know B equals 890. And now we just need to find A. As you can see over here, A, well, this, you can simplify it. So we need to find a number that you can divide from the top and the bottom so that the top is 1. So we could see that we could divide the top and the bottom by 89, which will turn the top into 1. So 1 over 890 divided by 89 equals 10. So A would equal 10. So this method is way easier than what my brother taught. So maybe try to use this method because it will be way faster and efficient. So, or the most thing you need to remember is to play with the numbers. They're toys that don't take up space in your house. Thank you for watching. Bye!